Hi, this is Seung, and I'm the Principal and Director of Sky Academy, and I just want to thank you for watching all the episodes up until now on probability, and you've made it. I just want to say that you've made it to the summary episode, unless of course you've done the naughty thing and gone straight to the summary episode and skipped all the episodes in between, in which case go back and watch the others, alright? But if you're watching this episode, I want to just quickly go through a summary of what we've done up until now, alright? Here's what we've done. We started off by looking at some definitions of probability and some words that you need to know that are often used in the study of probability. Okay, so probability, event or outcome, favorable, what's not favorable, sample space, it's the total number of outcomes that are possible in a given scenario. All right, and we've looked at basically the notation for probability, P outside of E, which means the probability, P for probability, of an event occurring, right? And the formula for probability, formula for the probability of an event occurring is the total number of favorable outcomes over the total number of outcomes, or possible outcomes. Does that make sense? And we've worked out that the probability of an event occurring is always going to be between 0 and 1. 0 meaning there's no chance of it ever happening, alright, it's got 0 chance of happening, or 1 meaning it's certain that it'll happen. In fact, that's the only scenario that could happen, okay? And then what we've looked at is not only the probability of an event, but we looked at probability of a non-event, of an event not happening, which is the complementary event of the probability that an event will occur. So we looked at what complementary events are, and we worked out that the relationship between an event and its complementary, event, is that if you add them together, they make 1. So if you want to work out the probability of a complementary event, you basically take the probability of the event away from 1, and vice versa. If you want to find the probability of an event happening, and you're given the complementary event, you take the complementary event away from 1. Cool, so we've done complementary events. And then what we did was we looked at the addition principle, all right? Which of the addition principle tells us that if there are mutually exclusive events and you want the probability of an event meeting one or more criteria, then you basically, probability of it meeting one or the other criteria will be the combined probability, and that's the probability of one criteria being met plus the probability of the other criteria being met, okay? So in other words, that's what we call mutually exclusive events, when you can add the two events together, and they're mutually exclusive because one event basically doesn't occur or can't occur simultaneously with another event. Okay, the two don't simultaneously occur, all right? Which means that we can add them together. Okay, so that's what mutually exclusive events are. When you're dealing with non-mutually exclusive events, what you need to realize is that you add the two together to find the combined probability. You add the two together, but you've got to take away the bit that overlaps. And the reason why you take away the bit that overlaps is because otherwise you're counting the overlapping region twice. So that's mutually exclusive, non-mutually exclusive events. That's the addition principle. We then moved on to successive outcomes, or multistage probability as it's sometimes known elsewhere. And we looked at, basically, when you've got the probability of one thing happening and you want to work out the probability of one thing happening as well as another thing happening at the same time, you multiply the two probabilities of each other. Okay? So the probability of A happening and the probability of B happening, you multiply them together, and that'll give you the probability of both A and B happening at the same time, okay, in the same event. Multistage events is what it's called. Okay, so that's the multiplication principle. And when you've got a probability tree, what you will realize is that the multiplication principle goes across the branches, the addition principle works down, okay? So as you go across the branches, you multiply, all right? And so we've looked, now that I've mentioned probability trees, we looked at probability trees, and we also realized that in some cases probability trees aren't the best way to graphically show all the outcomes in a multi-stage or a successive outcome scenario. And so we looked at probability trees as well as probability tables. All right. Now, when it comes to successive outcomes, we realize that there's two types of successive outcomes that you can have. You can have independent events, a multi-stage event where there's independent events, and multi-stage events where there's dependent events. And basically you know whether it's independent or dependent based on whether the next stage in a probability, whether the probabilities in the next stage of the probability depend on the event before. A classic example was of a dependent event probability is where you take a sample without replacing it, and every sample that you take, the probability of the next event happening will depend on the one before. Does that make sense? And so for a small sample, you've got to take that into consideration, the fact that each earlier event will affect the next one. Each earlier stage will affect the next one. But with a large population, you ignore the fact that taking one out of the population is going to affect the populations or the probabilities of choosing one event over one over the other scenario is negligible. Okay, so for a large population, it becomes negligible. And then independent events, most of the questions that you get, or the easier type of questions that you're going to get, are going to be independent. The trickier type of questions that you're going to get are the dependent ones. Okay, now most of the probability type questions that you're going to get, the challenging ones, are going to be in this region. Okay, the successive outcomes or the multi-stage event ones. Okay, so I would go away and practice some of those ones. But it's good to know all of this other stuff as well, okay? I would leave you to go away and do a whole bunch of questions on probability, and I wish you all the best in your studies for probability, okay? Thank you very much for watching.